Hello everyone, in this video we'll discuss about queue data structure. A queue is a linear list of elements in which all insertion takes place at one end, which is called rear end. And all deletion takes place at another end, which is called front end. A queue is based on the principle first in, first out. Whenever an insertion is made to the queue, the value of rear changes. If you want to insert element into a queue, then rear is equal to rear plus 1. Rear become 4. Similarly, when we delete an element from the queue, then the value of front changes. Front become front plus 1. If we want to remove the element at index 0, then front is equal to front plus 1. Front become 1. A queue is first in first out data structure in which the element that is inserted first is the first one to be taken out. The element in a queue are added at one end called rear and removed from other end called front. A queue is like a line waiting to purchase tickets, where the first person in line is the first person served. That is first come first served. Position of entry in a queue ready to be served, that is the first entry that will be removed from the queue, is called front of the queue. Sometimes we can call it head of the queue. And similarly, the position of the last entry in the queue, that is the one most recently added, is called rear or tail of the queue. A real world example of queue can be a single lane one-way road where the vehicles enter first, exit first. Queue is totally different from stack. In a stack, we remove the item the most recently added, but in a queue, we remove the item the least recently added. Stack is based on last in first out, but queue is based on first in first out. Then array representation of queue. Queue can be easily represented using one-dimensional array. Every queue having a front and rear variable that point to the position from where deletion and insertion can be done. Now in this queue, front is equal to 0 and rear is equal to 5. Now suppose we want to insert an element 45 in this queue. Then rear would be incremented by 1. Rear is equal to rear plus 1. Rear become 6. Now we can insert element at 6 index. Now front is equal to 0 and rear is equal to 6. Now if we want to delete an element from the queue, then the value of front will be incremented. Deletion are done from only front end. If we want to delete the element 12, 12 is at index 0. Then front is equal to front plus 1. Now front become 1 and rear is 6. Next is the algorithm to insert an element into a queue. Queue insert is the name of the algorithm, and this is the queue having 4 elements. N is the maximum number of elements which can be held in the queue. And front points to the front of the queue. Front is equal to 0 and rear points to the end of the queue. Rear is equal to 3 and item is the value which we want to insert into a queue. Item is equal to 12. and Q is the name of the array. First step of algorithm is if front is equal to 1 and rear is equal to n, then write overflow and return. That means Q is already full. We cannot insert element into a queue. Second step of algorithm is if front is equal to null. Front is equal to null means queue is empty. There is no element in the queue. Then set front is equal to 1 and rear is equal to 1. Else if rear is equal to n, then set rear is equal to 1. Now in this case, all the conditions are evaluated to be false. Then else part is to be evaluated. Set rear is equal to rear plus 1. Now in this case, rear is 3. Rear is equal to rear plus 1. 3 plus 1, 4. Then set Q of rear is equal to item. Q of 4 is equal to 12. This is a complete algorithm to insert an element into a queue. Next algorithm to delete an element from a queue. Queue delete is the name of the algorithm. Q is a linear array. N is the maximum number of elements in the queue. Front points to the front end of the queue and rear points to the rear end of the queue. First step of algorithm is if front is equal to null, then write underflow and return. Front is equal to null means there is no element in a queue. Then write underflow and return. Otherwise, set item is equal to Q of front. Item is equal to Q of front. Q of 0. Item is equal to 2. Then third step, if front is equal to rear, then set front is equal to null and rear is equal to null. That means if Q having only one element, and if you want to delete this element from the queue, then front become null and rear also become null. Else if front is equal to n, if this condition is true, then set front is equal to 1. Otherwise, set front is equal to front plus 1. Now in this case, all conditions are evaluated to be false. Then front is equal to front plus 1. Now front become 1. After deleting the element from a queue, front become 1. And then the fourth step is exit. This is a complete algorithm to delete an element from a queue. In next video, we'll learn link representation of a queue.